And the amalgam is based on alloy, like based on combination of mercury and silver or tin based one, and it is widely used for dental, applications. Okay, the beauty about is that of course they don't get corrode. Okay, and it can be shaped when you slightly, warming. Okay, you don't have to do, melt that alloy completely. Okay, and steels, so very well, like depending upon the type of carbon percentage, you can have plenty of types of steels. Okay, and you have a low carbon steel and high carbon steel, and of course stainless steel, which has slightly of chromium or copper combinations. Okay, and we do have a titanium steel, where you have a significant amount of titanium combinations in your steels. Okay, coming to the kind of processing or structure property relationships. Okay, so casting, which is one of the simple method, people widely use for metal based product manufacturing, and of course it has been started like 14,000 4,000 a year back itself. Okay, and it's very simple. You're gonna melt those concerned metals, and then you are going to pour those molten metal into the mold where you want to have those geometry, and then you're gonna apply the quenching, like with the help of either water or any other kind of combination of water and oil, etc. Okay, so now question is that, yeah, of course the other stuffs like any kind of complex shapes can be manufactured, and it's a very simple one, and cost effective also. Okay, as compared to other techniques, it has got a lot of advantages. Okay, and coming to the structure. Okay, so the iron carbon diagram. So you are studying different structure, right? Pure light and alpha, gamma, beta. So what is the fun of studying all those things? So at certain temperature, if you do the quenching, you'll get so and so phases, etc. So ultimately, what you learn from the phase diagram? Why everybody is talking about? Although I'm not metallurgy background, yeah, but still, like, why everybody is talking about pure light, bayonet, or uh, gamma phase, etc. Like, or a combination of two phases. Why people talk about that?
Take
Because
different
yeah,
properties.
exactly, yeah. So at certain, kind of protocol, if you do the quenching on so and so temperature, you'll get so and so phases, and that helpful for enhancing so and so properties. That could be of mechanical properties or some other properties. Okay, some other properties also means like kind of conductivity. Electrical conductivity or the thermal conductivity, because if you have those dendritic structure or some sort of like kind of, like microporous structures, you'll have better conductivity, etc. Okay, so same thing here. To get those, kind of desired microstructure, you will have to follow certain, protocol for your quenching things. Okay, so this everybody knows. Typically, typically like at the molten stage, kind of you have like a liquid-based metals. Okay, and the molten metal, and the moment when you reduce the temperature with the help of quenching media, the temperature will start to come down, and then over the period of time you'll get a completely quenched one, solid one. Okay, and yeah, that decide the shrinkage, all those things, like your finished product. Okay, so now coming to the microstructure. So this everybody knows that, like you have from the surface to the core. Okay, you have a different microstructure will form. Okay, once you've done with your fabrication process, quenching. Okay? So among these different structures, if you have these equiaxial structures, you are gifted one. You will have a kind of uniform properties, throughout your product. Okay, so of course that is going to be very tough job. It's very difficult to achieve. So yeah, with the help of those different protocol or some different quenching media, all those things you can play, and then make sure that you get a significant amount of equiaxial structure. Although the surface, the sidewall or something, the wall of your product, outside the surface, of course you'll have those equiaxial strengths, but when it comes to the closer, the core portion, you will start to lose those equiaxial zone, etc. Okay, structures, because the heat transfer will be pretty much slow when it comes to the, core section of your product. Okay. So there comes like advanced, material X, because you know that nanoparticles has excellent, performance, like in terms of mechanical properties or any other, special, focused properties. So nanomaterial also been used for, quenching media. Okay, that is called, you can say, like nanofluids or nanoquenchers. What they do, like they take some nanoparticles and then they mixed into your quenching media. So far, what are the quenching media you have seen? I mean, from your experiment. Although you are not done a lot of physical experiment here, but so far, what are the quenching media you know? Water, then oil, then
Ice,
what is that?
ice.
Okay, then
Air furnace.
yeah, that is common. But does anyone do that? I mean, with the help of air quenchant, will they make any product or what? Because I'm just asking, I'm curious. Like, so
Not
you
so
know,
sure. They just use.
okay,
Sir, air quenching is normalized in treatment.
yeah. So nowadays, what they do, like they use some polymer-based quenchant as well. That means like they take very small molecular weight of polymers, maybe of less than 10,000 gram per mole, that they mixed with the water, okay, to make sure that the boiling point is slightly getting, higher. So with the help of different polymers and their structures, you can play around with their, boiling point of your water. Okay, they mix with the water. Of course, to mix the polymer with water, I mean, it should have those solubility nature, like they should able to dissolve in the water. And again, this, I mean, not new one. I mean, this was developed 5-6 years back itself. And then further to enhance that, boiling, temperature of your quenchant or quenching media, they added these nanoparticles into that, media, okay, to again further enhance those temperature. Okay. So once you do that, I mean, then you can play around with your, morphology by either enhancing the heat transfer or slowly, reducing the heat transfer, etc. Okay. So the development of nano fluids are having high, based on like they have two different jobs, like high quench severity for enhancement of either heat transfer for thick section with low quenching sensitivity, and low cooling severity for thin sections with the high quench sensitivity. Okay, would be extremely helpful to the heat treating, community, or the heat treating of different samples. And the temperature dependent heat transfer coefficient and the wettability of the medium. I mean, that means like a media and then that your steel based product. Okay. So that ratio, all these things are very important. I mean, because when you mix polymer with water, they'll start to get, bind with your substrate. So that is also very important. I mean, wettability. It should not get bind with you on the surface of your metal-based product. And that's for like temperature dependent heat transfer coefficient and the wettability of the medium are two important parameters, and that can be used to characterize the nanoquenchant to assess the suitability for industrial heat treatment. And yeah, so this will be, very deeply in the next class, like different types of polymers, etc. Like how, nicely they are used for having those, isotropic structure, okay, or equiaxial grain-based structures. And if you want to know, if you're really more interested, you get some of the papers from Professor Prabhu. They have been working on this field for last 10 years. So you'll get more details, like what are the methods for different punching in media, etc. So you'll get to know from there. And yeah, rest of the things we'll see tomorrow. And what else? So you have a quiz in the afternoon. You please do it. And yesterday I forgot, so I came to know from Karthik that we have Thursday table. I missed it. Yeah, that's it. So anything else? Yeah, just we started. We'll see. I mean, more different concept in metal-based materials.
So can you please share the PPT?
Yeah, but still till here I shared, right? No. Okay, I'll do it. I'll do it.
Like some part of uh the content is not there in the PPT which you previously shared.
Okay, I'll do it now itself. Okay. I'll upload it and see you on when we are going to meet. We'll meet after Diwali. So Thursday is Diwali. Friday also I'll not be taking, but Monday we'll see. Monday we'll see sometime on. Yeah, you have a lot of free slot in the afternoon, right? Or no? This is same time. What about 4 to 5? Here. Because next week we'll try to complete I mean the courses, or the worst case we'll have again the next Monday, so that you'll have a lot of time for your preparing for your exam something. So 4 to 5 you are free, I guess. So we'll meet at 4 o'clock Monday, next Monday. So Thursday is holiday and Friday I don't want to take.
Okay, sir.
Yeah, okay, all right guys, then see you.
Thank you,
Thank you,
sir.
sir.